Well, can you believe it? We've already made it to Chapter 4. Section 4.1 is on probability. Actually, Chapter 4, Chapter 5, and Chapter 6 are all about probability, but in different ways. This section is a general introduction. As an example, suppose that you're at the gas station and you bought a lottery ticket. Then you look on the back, it says your chances of winning are 1 in 5. Hey, that's pretty good. Maybe I should buy 5 tickets, that way one of them's going to be a winner. Well, suppose you decided to spend $10, get 10 of those tickets, and they were all losers. Is that enough evidence to prove that the California lottery is actually lying to us when they said 1 in 5? What's the chances that that would happen, that you would have 10 tickets and all 10 were losers? Is there a 3% chance that happens to you? Is there a 90% chance that happens to you? Well, that's the type of question we're going to be able to answer. What are the chances, and is it likely or very unlikely? Now, what if you bought 100 tickets and they were all losers? That would be a really sad day. So, at what point do we have enough evidence to say that the California lottery is lying to us? Because if you bought 100 tickets and 1 in 5 win, supposedly, then that would be every 5th ticket, so that means you should have had 20 winners. Okay, then on to some of the language with probability. So an event, that's one possible outcome of an experiment. So I get the lottery ticket, I scratch it off, and I lost. Oh. So the event was, I lost. If I would have scratched it and won $1, the event is I won. Or you could flip a coin. If it's heads, that's one event. If it's tails, that's another event. So a possible outcome for your experiment. Experiment is just the thing that you did. Flipping a coin, so it doesn't have to be like a scientific experiment. I'm just flipping a coin. So usually capital letters are used for the events. And then P of A means what's the probability of event A. Here's an example. Suppose you draw one card from a deck of cards, and you've got 52 cards. In case you didn't know, there's 52 cards in a deck of cards, and you draw one. So let A be that you draw a queen. So the probability of it is, so there's 4 queens, the queen of spades, the queen of clubs, the queen of hearts, and the queen of diamonds. So there's 4 queens out of 52. And if you divide that, you'll get 0.077, or if you change it to a percent, it's 7.7%. If it's less than 5%, it's considered unusual. So this would not be considered unusual. So in general, when it says probability of A, then you just find out how many ways could A occur. There's 4 queens. What's the total number of possibilities? There's 52 cards. So 4 queens out of 52, and then you divide it. On to another example. What's the probability that you share a birthday with me, October 13th? Well, there are actually 365.24 days in a year because of leap year, but let's just go with 365. There's 365 days in a year. Out of those 365 days each year, how many of them are October 13th? You're right, just 1. So it's going to be 1 out of 365. What's the probability of being born on a Monday? So how many Mondays are there? Well, each week we have one day that's called Monday, and the total week, there's 7 days. So it's going to be 1 out of 7. Then for the next example, what's the probability of being born in May? You might think the answer is 1 in 12 because we have 12 months total. There's only one of them that's called May, so it'd be 1 in 12. The problem with that is some months count for more days than others. So some months are longer than others. So this one, I'm going to have to really break it down with days. So May has 31 days, January, February, March, April, May. See, it's on a knuckle. So that's a big month. That's 31 days. And there's 365 days total. So you could divide that and get the decimal 0.085. Or if you move the decimal to the right by 2 places, that's 8.5%. So it's not less than 5%. It's not considered unusual. Okay, now to a more specific question with the cards. So here's the playing cards, 52 cards. The top one are the clubs. This one is the spades, and then the hearts, and then the diamonds. 52 cards total. Suppose that you draw a card. Find the probability that you get a red 9. So how many red 9s are there? We've got 2 red 9s right here, the 9 of hearts and the 9 of diamonds. So that would be 2 out of 52. And if you divide that on a calculator and then multiply by 100, it will change it to 3.8%. What's the probability you draw an 8 or a spade? So this one is going to take a little more work. So for the 8s, so there is, here, let me get my laser pointer. There we go. So for the 8s, there's 1, 2, 3, 4 8s. So we have 4 so far. Now for the spades. So we're at 4, 5, 6, 7, 8, 9, 10, 11. Now this 8 I already counted, so don't count it twice. So I was up to 11. I have to skip this 8 because I already counted it. 12, 13, 14, 15, 16. Or another way to look at it is for each suit. So for the spades, if I count straight across, there's 13 of them. Then count this one, 14, skip, 15, 16. So it's going to be 16 out of 52. As a decimal, that would be a 0.308. And if you multiply by 100, it gives you 30.8%.